Hi. Now next recurrence relation. I have an example algorithm here. I'll prepare a recurrence relation and I will solve it. Now this time I will not be explaining each and everything. Already I have explained previous recurrence relation. The approach is same. So if you want explanation, you can watch at least one of the previous recurrence relation. Numbers are given beside the video, so you can check that. This one I'll just solve it with little bit of explanation. Let us find out a recurrence relation for this function. If I say this is taking Tn time, then inside this, these are the three main statements. This is taking 1 unit of time. Then how much time this takes? T, as this test is taking n, so Tn, so test of n minus 1 will be Tn minus 1. And also will be Tn minus 1. Then this is Tn is equals to all these. So Tn is equals to 2Tn minus 1 plus 1. Now the recurrence relation will be Tn is equals to 2Tn minus 1 plus 1 for n greater than 0. And when n equal to 0, it is constant, I take 1. Now let us solve this using recursion tree method, right? Tn. Now from the algorithm also I can see it is printing and calling itself 2 times. Printing and calling itself 2 times. So for printing it takes 1 unit of time and then it calls itself for n minus 1 and again call itself for n minus 1. Then what about this? This again 1 and call itself for n minus 2, call itself for n minus 2, and this also 1 and t n minus 2 and t n minus 2. Now what about these? Again 1 t n minus 3 t n minus 3 1 t n minus 3 t n minus 3. Then here also 1 t n minus 3 t n minus 3. This one is 1 t n minus 3 t n minus 3. If I go on doing it until when? Until they are reaching till t0 or t0, because here n is 0, that is the smallest value I know. So I want to keep on reducing it up to 0. Now let us find out time for this one. See, in this step, what is the time taken? Just it is taking 1 unit of time, and then I have to find out the time for this one and add them. So I don't know how much time this is taking. So if I look at this one, then this is taking 1 unit of time and further this one. And this one is also taking 1 unit of time and further this one. So let us add these two. So this is 2. So each is taking 1 unit of time. So that I have taken 2. Further, these are also there. Now if I take these 1, 1, 1, 1, 4. Then in the next step, if I expand these also 1, 2, 3, 4, 5, 6, 7, 8. So 8 steps. This will go on. So if I write this, this is 1, 2 power 1, 2 power 2, and this is 2 power 3. So how many times it will proceed? So as we have been doing for k times, so let us say this will go for k times, 2 power k times. Then it will become 0. At 2 power k, this will become 0. Now total time, how much is the time? 1 plus 2 square plus 2 cube plus so on. Now let me add all these, then I get the total time of this one. So I'll remove this and add them. Now it is 1 plus 2 square plus 2 cube plus goes on to 2 power k. This is sum of the terms of GP series, and this will be 2 power k plus 1 minus 1. How I got this, I will show you. This is the first time I am using it, so I will show you. If there is a GP series a plus ar square plus ar cube plus goes on to ar power k. R is a common ratio, A is a first term, and these are the sum of the terms of GP series. This is GP series. What is the answer for this one? A r to the power of k plus 1 minus 1 by r minus 1. This is the formula. In this series, what is A? A is equals to 1. What is R? R is equals to 2. It is getting multiplied by 2 every time. So if I put this in this formula, then 1 into 2 power k plus 1 minus 1 by 2 minus 1. So this is 1 only. So finally it is 2 power k plus 1 minus 1. So this is how I got the answer. So directly I have written this one. Now, as per the assumption already we were doing, assume n minus k is equals to 0. So therefore we were assuming it as n equal to k. So what is k here? N. So the answer is 2 power n plus 1 minus 1, and this is order of 2 power n. So it is 2 power n or theta or big O. This belongs to class 2 power n. Now I will show you another method. By using back substitution method, we will solve it. So I will remove everything and I will simply solve this recurrence relation. Now let us solve this using back substitution method. So I will take a recurrence relation Tn is equals to 2Tn minus 1 plus 1. This is the first one. Now what is this one? I will directly substitute this. So Tn is equals to 2 as it is. Now this can be written as 2Tn minus 2 plus 1, and this plus 1 as it is. If I open this, 2 square Tn minus 2 plus 1, 2 and plus 1. That's it. So this is the second equation I got after first substitution. Again, if I substitute Tn minus 2, this is 2 square 2Tn minus 3 plus 1, and outside this 2 and 1 are there. If I open this, 2 cube Tn minus 3 plus 2 square into 1, 2 square plus 2 plus 1. So this is the third equation I got. How this is happening you should know already, right? I am not elaborating the steps. If I continue this for k times, so this Tn will be 2 power k Tn minus k plus 2 power, see when this is 3, this is 3, so this is 2. So k minus 1, when this is k, so k minus 1 plus 2 power k minus 2 plus goes on to 2 power 2 plus 2 plus 1, and this is the fourth equation I have. Now this equation I'll write here and continue. Fourth equation I'll write Tn is equals to 2 power k Tn minus k plus 2 power k minus 1 plus 2 power k minus 2 plus goes on to 2 square plus 2 plus 1. We assume always n minus k is 0. See, all these are decreasing functions. N is reducing, subtracting functions, right? Decreasing function. So in this one, always we are taking n is equals to 0, and this we are getting it as 1. We are taking it as 1. So when n is equals to 0, that is the smallest value. So we assume that this n minus k has become 0. So when this is 0, n is equals to k, right? Now this is 2 power n t of 0 plus, what is this? I'll write it from that side. 1 plus 2 plus 2 square plus goes on to 2 power k minus 1. This will be 2 power n into 1. T0 is 1. Then plus, this is equal to what? 2 power k minus 1. So this will be 2 power n plus 2 power k is 2 power n minus 1. So this is 2 power n plus 1 minus 1. This is big O of 2 power n or theta of 2 power n. That's it. It is 2 power n. Now I'll show you Master's theorem for decreasing function. So in next video you can watch Master's theorem for decreasing function.